Hello, Sheldon McDonald here with Exploring Assembly Language 5, Part 2 of 2. Um, I was building a function to be able to load 2 bytes into a human readable string. Um, so just to recap on that video, I'll load my program here. Let's see. Okay, so a quick recap on that. Um, we added these two strings together, and we included my function here just to be able to print the text to the screen a little faster, rather than me pulling up a whole bunch of code for that. If you're curious how to print text to the screen, you can see one of my previous videos where I was doing that. I'm going to have a lot of shortcuts in my videos now that I'm building up a function library. Um, in fact, I've already technically wrapped these bytes into human readable string into a function as well. I've actually made that into str string, which is now a new function call if you have the latest version of rsdostool, which will be version 1.33. So that could be downloaded on my website, www.smotion3d.net. Let's have a look here. Caps. So once you get in there, you'll see it's at the very bottom of the directory. It says rsdoswin.zip. So you can download that. And for my tutorials, if you've been following along, you'll be able to click on the ASM tutorials. And this episode that I'm doing right now is exploring5.zip. So you can download that so you can follow along with what I'm doing. Okay. So we'll close that. So we went ahead and let's do a recap and just run this program and see what it looks like. So we got VCC here. I'm going to load that. I have my my drive set up. Okay, so we can go load m test and we can execute that. Okay, so you can see that we added two strings together. Okay, so if we go back to the code, yeah, we added this string into that string and we saved the end result into that string. So like I said, this is basically the core that we needed to build in order to be able to convert 2 bytes into a human readable word. So now we're going to go over to test2.asm. Go ahead and open that so you can follow along. So you can see here that I've made it into, I've added a lot more code to this, so we're going to go through it. This is the new subroutine that we're jumping to instead of the string A. This one's going to be referencing string A a whole bunch to do the math, to add the strings together. So right off the start, we're loading an address in. Okay, that's for our number. So if we have a look here, yeah, so we have the address word string, which is here. So I'm loading this into it. Okay. And we're storing D. So let's see here. Okay. So word has my actual number. Okay. This is where the actual number is in two bytes. Okay. And then I'm also I'm feeding it an address for it to store the answer as a string. So that's where our new number is going to be populated, and this will be a human readable string afterwards, okay, once it's gone through this subroutine. So I'm comparing D to 0. If it's at 0, then then there's no math involved. It's just print 0, right? Which is, if we look at the decimal number for that, is 48. So we just have to add the ASC code 48 and print it as a 0. Okay? So right off the start, we're jumping out of this loop if the answer is 0, because we don't need to test any of those bits at all. Loading Y. Loading Y with with number 2. Where do we got that? Let's take a look here. I'm just going to move this to the side. So we have our two numbers, A and B. Let's have a look. So what I'm doing here, I'm resetting the second number that we had from that original adding the two strings together. All I'm doing is resetting these back to zeros because it'll have junk data from the last time it was run. So right off the start, we're loading Y with that address. We're loading D with 3030 hex. So if I go to my converter here and I write 3030 hex, I'm actually populating it with 2 zeros at a time. So I'm storing D at Y and 2Y and 3Y, and there's a reason. I actually cut all these numbers down a decimal place. So we're not doing 6 digits anymore. Now we're doing 5. It doesn't make any sense to do 6 because you can't fit a word can only fit a value from 0 to 65535. So there's no point in having that 6 digit. Okay, so I just stored D. It kind of overwrote one of the zeros, and that's the reasoning there. Okay. Load X with the first byte. So now what's happened at the very start of this, we're jumping into this with our word, or our 2 bytes, and I'm storing that at A and B, okay? Since I'm storing D at A, it's actually writing our value here and here, okay? So I'm loading the first byte, okay? So now we're going to go through it and test every single bit. And so we start off by testing bit 128. If it's not equal, then we need to actually add that number to it. If it falls through, it'll go to the next bit. And again, branch not equal, we can go to, we have to add those strings together. So we'll look at we're going to get past all this branching here. And you'll see once we get down to here, I load in that second byte, okay? And this is the least significant bit. And then I got to do the same thing. I got to test all the bits again. So now we're up at the point where those labels were jumping to that we had to add the strings together. So this was the first one from the very start. It says branch not equal to STRA16. So if we go down to that, what we're doing there is we're loading the U register with the number 16. If you look at the little ASM memory tab here, you can see the number 16 that I have here is defined as 32768. That's the string that we'll have to actually add because that bit was set. And you can see that it's just divisible by 2. It goes all the way down to 0. Okay? So we're going to skip all of that now, because you can see what's happening there basically. I'm loading that string in, and then I'm jumping to that subroutine string A. And that's that first routine we made in the first video. And That first routine needed a little bit of changing to make it work as another subroutine for this function. I had to save the temporary number at the start, and I had to load our string that we're adding to it, or the one that's currently been added to, and we just end up going through. Actually, what this is doing here, I'm actually copying this string number, whether it's 16 or whatever. I'm copying it into this routine so I don't accidentally muck up the original values that are here, or else all your addition is going to be wrong. So I end up storing it at another location. So that's what I'm doing there. You can see that I'm loading U and I'm storing it at Y. So I'm just copying the U register string over to the Y register string. And then from there we can start adding the strings together and then jump back out of that routine. So that's why there's so much of that there. So once we get to the bottom of this, let's see. I've actually coded a nice little chunk of code here to get rid of those extra zeros. I played with the idea of, just cutting the string space right out, but it doesn't solve the problem of if their number was bigger and then it just got a lot smaller, it's going to have leftover garbage on the screen. So what I decided to do with this was just set it so those extra zeros at the start of your number, they're just going to be spaces instead. So what I got it to do is it's basically testing to see when it finds the first number that's not 48. And when you look at 48 here, that's when the first number that's not going to be a 0. So when that happens, I jump out of that loop. I go down here and I fill that space with an actual, I fill that 0 with a space instead. And we're going to run this and see why I did that. And I think it actually works a lot better that way. So we're going to load VCC again. I've already assembled this. So we'll go to VCC. So let's load M test 2. Okay. And we're going to execute that. So you can see here that I've got the space instead of it being filled with zeros. And I did that purposely. Like I said, if you end up cutting those out completely, you end up with garbage data once your number gets smaller, if it was bigger initially. Okay, so all I've done is I've created a space instead of throwing those zeros in. Okay, so that's that one. Now I also want to showcase that I've actually wrapped this into my function file. So we can go ahead and look at test 3 here now. If we look at this, you can see that there's not much code here at all. That's because it has my function library built in. Let's go through this and explain what I'm doing. I'm starting off with loading D with Word. So you go down here, Word starts off initialized as 00. Okay. I'm adding 1 and I'm storing it. So it's just a number that's counting up. This is the new function, strstring, and you can see it pulls up a little bit of information down here in red, and it tells you how to program it. It'll accept 2 types of numbers. You can type an actual number in there, or you can, you should be also able to type an address in. So what I've done on this first time that I jumped to strstring, I'm putting an actual number in it, and then I'm saving it under word string. So it ends up taking that number and it saves it here. That sounds pretty useless, doesn't it? I mean, you could have just wrote that into the string yourself. The point of that line is to just show you that it's possible to do that. Okay. Um, it can also accept a memory address, and that's where on the second line I've got it in the boxy brackets. I've typed the address word instead of the number. Okay. And then in boxy brackets again, I have the return address for that number to return to as a string. Okay, so the final result will end up in this location, and you have to make sure that you allocate 6 bytes of RAM space. Okay, you can see here that I've only allocated 5, but this compiler allows for the opcode FCN, which means it adds a 0 to that data structure. Okay, so there's actually 6 bytes of data there. So that's all you need to do is initialize your string that you're going to have your number returned to. And let's see how this one works, okay? So the top number should read 10,056, okay? And that's going to have a black background. And the other one is going to have a green background, and it's actually going to be counting. Okay, so let's have a look at VCC again. Now we're going to load test 3. So load m test 3, and we'll execute that. And you can see we've printed 1056. I just wanted to show that it works that way. But it also accepts a memory address of bytes. Okay, and that's the key to this this whole function, was to be able to convert 2 bytes into a human readable number. Okay, so there you have it. That's what I've done there, and now you have access to just calling str string, which is pretty dang cool if you're using my editor. All right, that sums up this video, and I think my next video is probably going to be just showcasing more functions that I'm building. For example, I want to start doing some graphics now, so I'm going to wrap the commands line and box into the semi-graphics standard mode, and then I'll end up taking it further as well. But for now, I'm just dealing with the main screen for the color computer. And once I get a lot of it done, then I'll start working on some of the higher resolutions. All right, thanks for watching.